Okay. We're going to talk today about logarithms. This is 1.5.2 and 1.5.3. So the first thing says evaluate log base 10.001. Well, you could do that in your calculator, or you can recognize that it is the same as what's below when I convert to exponential form, and that is 10 to the x equals 1 over 100, which means x equals -2 in both these cases. They're -2. Sometimes you get other bases that are not nice and you need a calculator. And guess what? If it's not nice or you don't know it, just use your calculator. This one's kind of interesting. Square root of 2 to the fourth power is 4. Square root of 2 times square root of 2 is 2. 2 squared is 4. We're going to go to example 3. We'll come back to example 2. We write this in exponential form. The trick here, log base 10 of 12 equals C. It's the base of the logarithm, which wasn't written there, to the power of what's it equals what's inside the logarithm. Um, Evaluate log 10 of 17. That's just a calculator problem. You grab a calculator, you plug it in, you get 1.23. Just use a calculator. That is not one that you can do by hand. A lot of these, it's just as fast to use a calculator. Okay, the pH scale is used to determine how acidic or basic aqueous solution is. Aqueous solution means something that's dissolved in water. The pH of a substance is given by the measure of the concentration of the hydrogen ions in the solution. It is defined as follows: negative log H plus equals pH, where H plus is the concentration of hydrogen ions in a solution measured in moles per decimeter cubed, I think. I'm not sure on that. Oh, I think that's cubic. I think that's per liter. I think decimeter cube, moles per. The -3 means it's on the bottom. You're going to see this notation in cognitive a lot. Moles, cubic decimeter. I think that's a decimeter is 10 centimeters. 10 centimeters cubed is 10 cubed is 1,000. 1,000 cubic centimeters is a liter, because 1 cubic centimeter is a milliliter. So that could also be moles per liter. So solution has this. Calculate the pH value. It's very easy. Make sure when you do the calculator, on the Inspire, you will have to enter the base 10. And you do that. And to grab the calculator. Um, and I get, well, I guess I didn't enter the negative, but I get a pH of 3.24. This one tells me the pH and it asks me for the hydrogen ion concentration. H plus just means hydrogen ion. So I'll move the negative to the other side, and then I'll convert to exponential form. So this gave me 0.00002. I didn't like that very much. So I hit answer times 3, and then it actually wrote out the answer for me. 1.65, rounds up to 66. 66 times 10 to the -6. It then wrote it out. What I did was I just hit times 3 and it gave me the previous answer and it gave me a whole lot more decimals that way. Okay, now we're going to go back to example 2. So show that log b is only defined for b greater than 0. So log 10 of b equals x. So 10 to the x equals b. And I can say that that's got to be positive because this exponential equation has a lower asymptote at 0. 10 to the x is a graph that looks like this. So b has to be greater than 0. And evaluate log base 0 on your calculator, or log of 0. And that gives you undefined. Not greater than or equal to 0, greater than 0. Okay, on to 15.3. Natural logarithms. I encourage you to watch The Number E is Everywhere video. It's kind of interesting. Good ideas to see and be familiar with. Log base E of x is abbreviated with ln x. And you should know ln's from previous courses, but that's what it is. It says rewrite ln2 equals c in exponential form. To make this easier, I will go log base e of 2 equals c, e to the c equals 2. That is this in exponential form. Evaluate ln 5. You just grab your calculator, you type in ln 5, and you get 1.61. Example 3, determine which of the ln2 or ln15 has the smallest value. Well, that's ln2. A natural log and all logarithms have a graph that is the inverse of an exponential. This key point here is 1, 0. There's another point that the natural log is going to go through. E1. It's all logarithms go to the point 1, 0, and whatever the base of the logarithm is with the natural log, it's E1. Okay? And then they have a vertical asymptote on the y-axis, or at x equals 0. So, in the computer industry, The strength of a password is usually measured in terms of its information entropy, H, which is given by the following formula. L equals ln n over ln2, where L is the length of the password and n is the number of possible symbols that can be used in the password. What is the information entropy for a password of length 8, where the symbols that can be used digit are either a number digit or a letter from the English alphabet. The letters can be lower or uppercase. So that means if they can be lower or uppercase, assuming that's different, that's 26 plus 26 plus 10, that's 62, I believe. So H equals L is 8 times ln 62 over ln 2. And I can go ahead and stick that into my calculator. And I get 47.6. Yep. Now it says to do that to find where it's greater than 64. So I set up the equations. I don't know the length here. Still 62. So I'm going to multiply 64 by the reciprocal of what's on the other side. So it's going to be ln2 over ln 64 or 62. And that's going to be the length of my password. And I've got 10.74, so this has to be length 11. Has to be at least full 11. So, theory of knowledge. As discussed in this section, logarithms are mathematical knowledge created that then is used to create future knowledge. When using a log table, one does not check the validity of the mathematical knowledge with the log table, it's simply trusted. This trust as previously established knowledge results in a system of knowledge that is said to be priori free from first-hand experience. This leads to the knowledge question. To what extent is the validity of knowledge predicated on sensory perception? Interesting question. I don't think we have a whole lot of sensory perception around the validity of logarithm knowledge, although there is some visual knowledge and understanding of inverses. Interesting question to think about. Okay, that is the end of this video on logarithms.